In this problem, we're going to solve a quadratic inequality by using a graph. We want to solve the inequality x squared minus 10x plus 24 is greater than or equal to 0. We're going to start by graphing the function f of x equals x squared minus 10x plus 24. And we're going to find the x and y intercepts. We'll also find the vertex, and we'll use those to sketch a rough graph. The y-intercept, you can see from our function, will be this constant 24. We'll just write y equals 24 for our y-intercept. To get our x-intercepts, we're going to set our function equal to 0 and solve the resulting equation. So 0 equals x squared minus 10x plus 24. We'll solve this by factoring. We'll get x minus 4 times x minus 6. Set each of these factors equal to 0 and solve. And we'll get x is equal to 4 and x is equal to 6. So we have two x-intercepts, 4 and 6. We'll also find our vertex. We can get the x-coordinate of the vertex by using negative b over 2a. Come back up to our function, see that a is equal to 1, b is equal to negative 10, and c is equal to 24. So we'll have x is equal to negative 10 over 2 times 1, which is 10 over 2, which equals 5. We get the y-coordinate of our vertex by evaluating our function at x equal to 5. As we'll find f of 5. So we'll get 5 squared minus 10 times 5 plus 24. And if we evaluate that, we'll get that f of 5 is equal to negative 1. So our vertex is the point 5, negative 1. So we have a y-intercept of 24, x-intercepts at 4 and 6, and a vertex at 5, negative 1. We're going to use those points to sketch a graph. We'll plot our intercepts. We first notice that the scale that we're using, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. We're going up to 30, so each of these tick marks represents 3 units. Along the x-axis, each tick mark will represent 1 unit. We want to plot the y-intercept, which is at 24, so we need 8 tick marks. 1, 2, 3, 4, 5, 6, 7, 8. So that's 0, 24, our y-intercept. We had x-intercepts at 4 and 6, 2, 3, 4, 5, 6. And then our vertex was at 5, negative 1. And this intercept is 6, 0, and this is 4, 0. Now if we do a quick sketch connecting these points, see the graph of our function that we had defined as f of x is equal to x squared minus 10x plus 24 will look roughly something like this. We're really looking for where this quantity is greater than or equal to 0. From our graph, we can see that we'll have f of x greater than or equal to 0 for values of x that are less than 4. It's greater than 0 for values of x less than 4, and for values of x that are greater than 6. Since the inequality is not strict, we also include values where the function is equal to 0. That's at 4 and 6, so we'll include those in our solution set. So the solution set to our inequality is the set of all values for x such that x is less than or equal to 4, or x is greater than or equal to 6. We write this in interval notation of negative infinity to 4 using a square bracket, union with 6 to infinity, again a square bracket on 6.